Hi, my name is John.
And my name is Alice, and we're Math Videos for Parents. We help you so you can help your child. Today we're going to be talking about greatest common factor. So if I was asked to find the greatest common factor, which is abbreviated GCF often, of 60 and 144, I'm basically trying to find the biggest number that can go into both of these numbers cleanly. And just eyeballing it is almost impossible. So what I'm going to do is something called factor trees. Now, if you're not familiar with factor trees, I recommend you watch our video on prime factorization if you want a deep dive. But let me go into this and just kind of give you a little refresher. So if I want to make a factor tree of 60, I'm going to ask myself, what two numbers could I multiply to get 60? 6 and 10, for example. No, there can be other ways to approach it, of course. You could have done 20 times 3. So I got 6 times 10. Now, what two numbers could I multiply to get 6? And I'm going to say 3 and 2. What two numbers could I multiply to get 10? And that's going to be 5 and 2. Now, each of these numbers at the end here is a prime number. They can only be divided by themselves or 1. Another way to think of it is the only way to get to multiply two numbers to get 3 is to multiply 3 and 1. So that's a prime number. It can only be achieved by multiplying by itself and 1. So 3 is prime, 2 is prime, and 5 is prime. So I'm going to leave that factor tree as it is. Don't worry, we'll get back to it. And now I'm going to approach 144. So I'm going to say, well, let's see, 2 times 72 gives me 144. Any number that's even is divisible by 2. 72 is even, so I knew 2 is going to go into it cleanly. As 2 times 36. 9 times 4 is 36. And 3 times 3 is 9. And 2 times 2 is 4. And you might have wondered why I kind of abandoned these branches. That's because they already kind of resolve themselves into a prime number. So what I'm going to do here, and I'm sorry, John, I'm going to take your slide. I need your half, and we'll come back to your approach. I'm going to write out 60 is 3 times 2 times 5 times 2. I was just reading along the factor trees. The same with 144. I can say, okay, 144, reading every branch of the factor tree, is 2 times 2 times 3 times 3 times 2 times 2. And let me just circle that here, just so it's really clear where those numbers came from. That's there. And then these numbers here for 144. Okay, so now we're almost there. So now we just have to ask ourselves, what do these numbers have in common? So let me take another color and say, okay, I'm just going to go left to right with 60. 60 has a 3 here, and 144 does as well. So I'm going to circle that as something they have in common. 60 has a 2, and 144 does as well. 60 has a 5. 144, if you read along left to right, there's no 5 there, so I'm not going to take that into account. 60 has another 2. 144 has another 2. And now we've run out of material, right? We have nothing left. So I'm going to say, okay, the greatest common factor is going to be 3 times 2 times 2, which is what they had in common. And 3 times 2 is 6. 6 times 2 is 12. So the greatest common factor for these two numbers is 12. John, I'm sorry I took your slide. So let's pause. You can create one, and you can show us how to do it with repeated division.
My pleasure. Okay, so repeated division. If you saw our previous video on using repeated division to identify a prime factorization of a number, you saw the advantage of it in that it takes a large number and breaks it down very quickly into smaller numbers. It's equally as useful and helpful for greatest common factors as well. And the way we set this up is we take our given numbers, in this case 160 and 144, and we repeatedly divide them by prime factors, things that we know go into each number. Because these values are both even, I'm going to start with 2. I know that 2 goes into 60 30 times, and that 2 goes into 144 72 times. I'm now left with 2 more even numbers, so I can divide those each by 2. Now I'm left with 30 divided by 2, which is 15, and 72 divided by 2, which is 36. 15 is not even, so I think I'm done with 2. However, using a little quick trick, adding the digits up, 1 and 5 makes 6, 6 and 3 makes 9. Both 6 and 9 are multiples of 3, so I know that 3 goes into both of these. I'm left with 5 and 12 as my numbers. 5 and 12 don't share anything in common, so I've reached the end of the road, and therefore my greatest common factor is the product of these 3 values that we found went into both of our numbers, which is 2 times 2 times 3, or 12. So I was able to do this in a nice condensed way, and we gradually saw each number become smaller and smaller through a process of repeated division.
That approach is much faster. I am eager to try this approach. I think I could not spill over into your slide. Also, I just want to point out the fact that 12 is the remainder of 144, that's a complete coincidence, right?
Correct.
Okay, perfect.
All right, go.
Okay, so now I'm going to find the greatest common factor of 252 and 270. So I'm going to write them both here.
Those are large numbers.
They are, but I'm confident with this approach I'll be able to handle it in a pretty straightforward way. So I'm going to ask myself, what number goes into both 252 and 270? They're both even. What prime number goes into them? So 2 goes into them. So 2 goes into 252. Let's see. 2 goes into 24 12 times. 2 goes into 12 6 times. And then 2 goes into 26 13 times. And 10 5 times. So now 2 won't go into 135 because it's odd. So the next number up would be 3. 6 plus 2 plus 1 is 9. So 126 is divisible by 3. 135, 1 plus 3 plus 5 is also 9. 9 is divisible by 3. So I'm going to put a 3 here. 3 goes into 12 4 times and 6 twice. Now I'm going to tackle 135. 3 goes into 13. So now I've got 42 and 45. I would try 2, but it won't go into 45. So let's see. 4 plus 2 is 6. So 42 is divisible by 3. 4 plus 5 is 9. So that's also divisible by 3. So that's wonderful. Okay, so now let me check out 14 and 15. 15 is not even, so 2 won't go into it. 3 won't go into 14. 4 plus 1 is 5, which is not divisible by 3. I'm just kind of going up in my mind the prime numbers. Next one would be 5, but 5 won't go into 14. Next one is 7. 7 won't go into 15. So I feel confident that we can call it a day. And I'm going to say, okay, the greatest common factor, is going to be 2 times 3 times 3. It's going to be 18. John, this is a much more straightforward approach. Much as I like factor trees, I really like this approach.
And stealing my slide.
I do like that. So we hope this was helpful for you. Thank you for watching Math Videos for Parents.
Have a great day.